Hello everyone, welcome to my session Scaling to Success, leveraging KEDA and Kubernetes for optimal Azure DevOps pipeline performance. Before I start, a couple sentences about myself. My name is Wolfgang Ofner and I'm a freelance cloud architect and I'm currently located in Perth. For the last 6 years, I lived and worked in Switzerland and I'm still working for Swiss clients. My focus is on Microsoft technologies, especially on Azure and .NET, and there I specialize on Kubernetes and DevOps. If you have any questions or want to contact me, feel free to message me on LinkedIn, on Twitter, or on my blog. So today I want to give a short history of the architecture and software projects. Then I want to give an introduction to KEDA. Then I'm going to show you a demo application where we use KEDA to scale our Azure DevOps agents that are running inside Kubernetes. And at the end, I give you my opinion of KEDA. So a bit of history. Let's look back in the days. The architecture of our software was very simple. We often had a server and only a handful of clients. And since this was so simple, we didn't need redundancy, we had no high availability, so if the server crashed, the clients couldn't work, but since it was so simple and so many people used it, it was okay. And then in the early 2000s, we discovered that we can create virtual machines, and this made it way easier to spin up new machines and also add load balancing to our applications. Another reason, the internet got more and more popular, so we had a high demand, and we also wanted to make sure that our customers and clients have a great experience when they use our service. Back then, everything was static, so we had to create a load balancer, we had to create the VMs, we had to add the VMs to the load balancer and make sure that everything works. So it was an expensive on-premise operation. And it needed a lot of time and also manpower. And then the internet, especially online shopping, became more and more popular, and also around 2010 cloud services became popular. So we had cloud services like the Azure App Service, which allowed us to do everything we had to do by hand before automatically. So with the Azure App Service, we can create automatically new instances and also add them to the load balancer automatically, so we don't have to do anything and it can happen within seconds. The scaling mostly works based on CPU or RAM usage. So if we saw that our server had too many requests, so the CPU usage was high, Azure could just automatically add new instances. And another great feature was that we only have to pay for what we used. For example, if we had a busy day, we added new instances, we paid more on this day, which was fine because we made more money on this day. And during the night or off-peak times, we just scaled down, removed the resources we didn't need, and therefore also paid less. And nowadays we have architectures that look like this. I don't want to go into the details, I just want to show how complicated software has become in the last couple of years. So on top here we have two Kubernetes cluster, and then we have some Java services and some disks we have to manage. We have a lot of data. So we have the Azure Data Factory or some databases. We have caching. We have on-premise work. We have cloud work. So it's so much more that we had before. And therefore we also needed new ways to scale our applications, because scaling based on CPU or RAM usage is nice, but as you can see in this picture, it's not sufficient anymore for our use cases. And around 2015, 2016, Kubernetes became popular, and Kubernetes has a service or resource that's called the horizontal pod autoscaler, the HPA. And this resource helps us to scale our applications. It can scale based on a CPU or RAM usage, and it helps us to run our applications inside the Kubernetes cluster smoothly. But as I said, the architecture gets more and more complex, complicated, and we have a lot of dependencies on external resources, and we also have often to react to events. So if something happens, our application has to do something. And these events can happen literally everywhere. This could be in a database, we can get a service bus message from an IoT device, we can see something in a stream analytics, or Azure Monitor sends a notification. So again, scaling based on CPU and RAM usage is not enough. Just a couple of words to the horizontal pod autoscaler. What it does, it scales deployment sets or stateful sets. These are both resources inside the Kubernetes cluster, and simplified, what they do is run our application. And what the HPA does, it adds or removes pods. So pods are the smallest unit inside Kubernetes, and you could think of container. Again, simplified, but you can think one pod is one container. And as I said before, it can do the scaling based on CPU and RAM usage, but you can also write custom metrics. The problem with this is, I as a developer, I'm not really interested in writing requests against the Kubernetes API or against Prometheus, because suddenly I have to learn a whole bunch of new tools and how this works. And also as an operations guy, I'm not really interested in writing all these queries. It would be way better if something came out of the box for me. But something you can do with this is, for example, you could scale based on requests per second, because that's stored in Prometheus, but it's very cumbersome, so it's not a great solution. And here we see how the horizontal pod autoscaler can be configured. So on the left side, we just give it a name and in what namespace it should run. Then we can configure the minimum amount of replicas and the maximum. So we want to have between 1 and 10 instances of our application running. Then we say we want to scale based on the CPU usage. So the average CPU utilization should be 50%. This means if it's higher than 50%, we scale out. And if it's lower than 50%, we scale down. And the last thing here is the target reference. So we say we want to scale a deployment, and it has the name custom API. And this deployment is running my custom API application. And then we have the behavior. There we can configure how the scaling should behave, when it's scaling out or down. So we do this with this here for the scale down policies. There we can say we want to scale down based on pods, so that's a number. So when we scale down, we want to scale down by 4 pods. So every time we scale down, we remove 4 pods, and then we wait 60 seconds. But you can also do this with percentage. So in the second example, we want to scale down by 10% of our applications. And then we have the same with scale out on the right side. So we want to scale out by 5 pods or by 12%. As I said, there are some limitations with the HPA, especially when you try to scale based on CPU and RAM usage. And a great example is the Black Friday. So if you have an online shop, it's common that you place the order in a queue and another application processes this order. This provides the customers a great user experience because they place the order and 2 seconds later they get a notification the order has been placed. And you might notice from Amazon, they do this, and if something goes wrong, you get an email. For example, 50 minutes after placing your order, you get an email that your credit card got declined. And this is 50 minutes later because another service processed your order back then. And as I said, on Black Friday, we have hopefully lots of customers which place many orders. And if they place hundreds, thousands, or even tens of thousands order on that day, and we have one application that is processing the orders from the queue, it might take forever, and our customers won't be happy if they get the order 2 weeks later, only because it took us 2 weeks to process the queue. And since the messages are in a queue, we can't use a CPU or RAM usage to scale our application. So in this scenario, we don't have any option to scale our application automatically. And this is one of the reasons why KEDA, the Kubernetes event-driven autoscaling, was invented. KEDA is an open source project. It's also a CNCF, a Cloud Native Computing Foundation project. And it's maintained by big companies such as Doc Planner, Microsoft, or Red Hat. And a great thing about KEDA is that it has a lot of built-in scaler. The last time I checked, it was over 53. I think by now it's already over 60. It's every couple of weeks new scaler introduced. And the scaler are for literally every technology you could think of. So we have Apache Kafka, that's a streaming service. Then obviously we have a lot of Azure services like blob storage or monitor. We have Elasticsearch. Then we have databases such as MongoDB. We can analyze Redis streams. And I have to admit, I probably never used 2/3 of the technologies that are available. And the use cases of KEDA are, as I mentioned before, you can scale according to external events. For example, if I have many messages in my service bus, I can scale based on this, but I can also scale to 0. And scaling to 0, you might know from a serverless architecture. For example, Azure Functions, that's a serverless technology. They are scaled to 0, and when they receive a request or a trigger, then they scale up and process the request. And once they're done, they scale down to 0. And with KEDA, you can also bring this technology to your own data center if you're running Kubernetes there. And a great example would be, again, an online shop. So during the day, you have the customers on your online shop. You want to provide them the best user experience, so you use all your resources for the website. And at night, there are usually way less customers, so you can scale down the website a bit, but you can scale out background processes. For example, calculating shipping labels or calculating loyalty points, creating the receipts. And in the morning, the processing of all these background tasks is hopefully finished, so you can scale them back to 0 and scale up your online shop again. Another great feature about KEDA is that it's really simple to install. It can be installed by Helm charts, and the only requirements it has is that it runs inside the KEDA namespace. Otherwise, the installation won't work. So what you have to do is, the first thing is you create the KEDA namespace. It's right here. And then you add the Helm chart of KEDA, make an update to make sure you have the newest version, and then you install this Helm chart inside the KEDA namespace. And once everything is installed, you can see that you have two applications running here. First, we have the operator, and then we have the metric server. And the operator is also sometimes called the KEDA agent. This application is responsible to scale to 0 or from 0 up. And the metric server is responsible for scaling if it's more than 0 or not scaling down to 0. It does this by sending the data or the requests to the horizontal pod autoscaler, and then the horizontal pod autoscaler does the scaling. And since it uses resources that are already in Kubernetes, you can add KEDA to your existing application, and you don't have to change anything. Especially the developers don't have to change anything inside their code. And here we have an overview of the architecture of KEDA. So on the bottom here, we have something happens, an event, a message in a service bus, something in a database, and then KEDA decides, do I want to scale from 0 up or from a number down to 0, then it uses this path, then it uses the KEDA agent or operator, and if it's scaling from more than 0, this means for example from 1 to 5, then the matrix adapter sends here a message to the horizontal pod autoscaler, and the horizontal pod autoscaler then scales our application. And everything we need to scale our application are two custom Kubernetes resources. The first one is the scaled object, which will contain all the information to scale the application, and then the trigger authentication, which allows the scaled object to authenticate against the source of the scaling events. So here we have the scaled object. So it's in Kubernetes the kind of scaled object, and here in the specifications we can configure how it should behave. So here we have a target. The target is the KEDA demo API, so that's the name of our application. Then we say we want a minimum of 0 replicas. This means we can scale down to 0, and a maximum of 10 replicas. Then next we have a polling interval. This means that KEDA checks every 30 seconds if it should scale up and down. And we also have a cooldown. This means after a scale event, it waits 30 seconds to check again. I used 30 seconds because it's easier for a demo, so we don't have to wait that long. The default value is 5 minutes, and it also makes sense in a production environment to wait a couple minutes and don't scale every couple seconds. And then on the right side we have here the trigger. So it's of type Azure Service Bus. So we scale our application if something happens to an Azure Service Bus, and then we configure the queue name. So the queue name is KEDA demo, and the queue length is 5. This means if we have more than 5 objects in our KEDA demo queue, KEDA scales out our KEDA demo API application. And at the bottom here we have a reference to the authentication, and that's the second file we're gonna create on the next slide. So here we have the trigger authentication. That's again its own kind in Kubernetes, and here it has the same name as we referenced in the file before. And what it does, it references a secret in Kubernetes where it can find the connection string. So here the name of the secret is KEDA demo API-connection strings, and inside the secret is a key named Azure Service Bus _connection string. And if you go to the Kubernetes CLI, you can also find the secret. So if you use kubectl get secrets, you will find all the secrets, and there you can find the KEDA demo API secret. And then you can say kubectl describe secret and provide the name, and then on the bottom you can see the key which I referenced before. And if you prefer to use the dashboard, you can see it there the same. Like you go to secret with the name, and there you can find the key inside. And now I want to show you how you can leverage KEDA to run your Azure DevOps agents inside a Kubernetes cluster. So first we're gonna run it locally, and then we deploy it to Kubernetes, and once it runs in Kubernetes, the agents will be scaled down to 0. And if we start a pipeline job, KEDA will automatically scale them out, so we have as many agents running as we need. And to do this, first we have to do a couple preparations in Azure DevOps itself. Then we're gonna build the Docker image locally and also test it locally to make sure everything is working. Then we're gonna deploy it to Kubernetes. So we have one agent in Kubernetes running, and then we're gonna apply KEDA so we can have the scaling. So to do this, let's go first to our Azure DevOps server. And what we have to do there is to create a personal access token so that KEDA or the Azure DevOps agent can access our Azure DevOps server. And to do this, you have here on the bottom, on the top right, the user settings, and then personal access tokens. and then you click on add a new token. You give it a name, for example, KEDA ADO agent. It can expire in 30 days, and then what it needs access to read and manage agent pools. That's all the access it needs. Then you click create, and then it gives you the token. And what's very important is that you copy this token here. That's the only time you see this token. So if you close this window, you have to create a new token because you don't have an access to it anymore. So I'm gonna save this here on the side. And what I then have is I have all the files on GitHub. So I have the Docker file, I have a Azure DevOps pipeline, I have the deployment so we can run it in Kubernetes, and KEDA to scale the jobs. So if you're interested, you can find all the files after the session there, and you can try it out yourself. And I also have them open here in Visual Studio. And the Docker file to build the Azure DevOps agent is provided by Microsoft. But since it's a Docker file, you can add everything you need. So what I added here is the wget command. And here I also install the .NET SDK for version number 6 and 7. So my Azure DevOps agent will be able to build .NET applications for .NET 6 and 7. But since you can add whatever you want, you can add Java, PHP, everything you need. And you can see here on the bottom, you have the entry point is a file called start.ch. That's also a file provided by Microsoft. And what this file does, it configures the Azure DevOps agent. So we don't have to do anything, we just take it as it is. And again, you can go to my GitHub and read it there if you're interested. So what we're gonna do now is we're gonna build this Docker file, and then we provide a name with the -t tag, and I name it ADO agent KEDA. So this is already done because I did it before. Since the image has, I think, more than 1.5 gigabyte and my internet connection is a bit slow, so I didn't want you to wait here. So we have the Docker image built, and next we can already run the image. And what we have to do now is we say Docker run and provide a couple environment variables to configure the Azure DevOps agent. So I've already prepared the command. So let's paste it in here and let's see what this command does. So first we say Docker run, it's standard. Then we provide a couple environment variables. The first one is the URL of your Azure DevOps server. Then the second one here is the private access token, the one we just created. Then you provide a name for your agent. This can be anything, so I just name it agent. Then you have to provide the pool for your Azure DevOps, where the Azure DevOps agent will run inside, and then you provide the name for the image we just created. And what this reminds me of is that I forgot to create the agent pool. So we have to go back to our Azure DevOps server. And if we go to our settings, we can see here on the left side agent pools. So you click there and click here on the top add pool. So we select the self-hosted because we run it ourselves. Then we provide a name. This was KEDA as before, and I give it access to all my pipelines because I want to use it everywhere. Then we create this, and now the Docker run command should work. So let's try it. So what it does now, it looks, or it starts the start.ch file we've seen, and this file tells it to download the Azure DevOps agent. So that's what it's doing right now. And it's gonna take a couple seconds depending on the internet speed, and then it will start the agent and also connect to your Azure DevOps server. So, and now the agent is started, it connected to the server, and on the bottom here we can see it's listening for jobs. So if we start a pipeline now, it should pick up this pipeline. So to test this, let's go back to our Azure DevOps server. And they have a demo project, and inside this demo project I have a pipeline so we can test the new agent. And inside this pipeline, what's important is that you use the pool you created before. So the KEDA pool is the one where our Azure DevOps agent is running inside. And the job is as simple as it can be. It runs an empty bash script. So it literally just checks if the agent can pick up this job. And if you run this now, it's gonna take a couple seconds, but then I expect the Azure DevOps agent that's running on my computer inside the Docker image will pick up this job and successfully run the pipeline. And there it already finished. And if you look into our command line, we can also see the job succeeded successfully. And what it also does, it does a cleanup. So once the agent ran, it shuts down the agent. So now we know that everything works great. And the next thing we have to do is deploy it to Kubernetes so we can run it from there. Before we can do this, we have to push it to a container registry. So we can use, for example, Azure Container Registry, but I'm gonna push it to Docker Hub so you can download the image and try it out yourself if you want to. And to do this, first we're gonna have to tag it. So what we do here is we tag the image we created before with my name on Docker Hub and the name it should have on Docker Hub. And the next step is that we're gonna push it to Docker Hub. So again, depending on your internet connection, this might take a while. So I'm gonna be back once this is finished. So the image has been pushed to Docker Hub, and what we can do now is prepare the deployment for the Azure DevOps agent inside the Kubernetes cluster. To do this, I already prepared here the Kubernetes deployment. Again, you will find it on the GitHub. And what you have to do is you have to change a couple of values. I always added this comment. So if you try it yourself, you should find it quite easily. And the first thing we do is we're gonna create a new secret. And this secret will contain the Azure DevOps private access token we created before. But since it's Kubernetes, it has to be base 64 encoded. So I took the access token and encoded into base 64 and pasted in there. And the second resource we have to create is a deployment. And this deployment is going to take care of actually running our agent. So again, if we scroll down, you can see the values you have to replace. The first thing is going to be the image. If you want to use your own image, that's the one I just pushed to Docker Hub. Then your own Docker Azure DevOps server URL, and then what pool name you gave. So if you use the same as you can leave it as it is. And then we go back to the command line. And what I want to do is I want to create a new namespace and run the application there so it's easier later to remove everything. So I'm going to create a new namespace named ADO-agent. And then I set the context to this namespace so I don't have to edit every time I execute the command. And then we can deploy the file I just showed you. And now we can check how long it takes until this pod is created. This should take around 1.5 minutes, again, since the image is quite big, so I will be back once this image is created. So the pod has been created and our Azure DevOps agent is running inside the Kubernetes cluster. And what we can do now is go back to the pipeline and test if it's working with this agent. So we just go to the same pipeline as before, run it, and it should take a couple seconds and the pipeline should be executed successfully. And there it is. Everything worked as expected. And if we go to the agent pools now, we will also see in our KEDA agent pool, the one we created before, our Azure DevOps agent. There you can see that the agent is inside there, it's online, so everything is working fine. But what we do now is we deactivate this agent because we want KEDA to scale our agents. And the reason we created this agent before is Azure DevOps specific. An agent pool always needs at least one agent, otherwise it can't use this pool to pick up a pipeline job. But if you have a deactivated agent inside, everything will work fine. And to deploy KEDA, I have another file for the scaled job. So that's what I said before, that KEDA uses this scaled job object to scale the applications. And there we give it some information. Again, what image it should use to scale our agent, then the URL to the Azure DevOps server, then here the pool name. And if we scroll further down, here we have the pool ID. And to find this pool ID, you can use this URL, just replace your organization here with your actual name, and then you will find all your agent pools. And in my case, the pool ID is number 12. So everything is set up and we can deploy KEDA in our Kubernetes cluster. So we go back to the command line and apply the file we just looked at. So this configures KEDA and then we can check what pods we have running. And as you can see, we have one pod running. That's the one Azure DevOps agent we created before. And once we start a pipeline, I expect KEDA to spin up new Azure DevOps agents and run as many agents as we need for the pipeline. So to test this, let's go back to Azure DevOps, to the pipeline. And what I have here is a pipeline with 5 jobs. And all these jobs do is wait for 5 minutes. But what I expect KEDA is to create 5 agents because I have 5 jobs and run them all in parallel. So let's try this. So you can see we have the 5 jobs, they are queued. And if you go back here, we can see KEDA is scaling our Azure DevOps agents from 0 to 5. So we have 2 already running and 3 more being created. So they are slowly coming in. And if you go back to our Azure DevOps, it takes a couple seconds until the jobs actually start because the Azure DevOps agent inside the pod also needs to be configured. But in a couple seconds, I expect the status to change from queued to running. And there we can see we have 2 jobs running. But you might have expected that we have 5 parallel jobs running. And that's another limitation of Azure DevOps. My Azure DevOps organization only has the licensing for 2 parallel jobs. And it doesn't matter that I have 5 agents available. The license only allows 2, therefore I have only 2 jobs running at the same time. And KEDA doesn't know this, so KEDA scales to 5 jobs because it thinks it needs 5 agents to run the 5 jobs of the pipeline. So we can cancel this, but we saw that everything is working. And if you go back to our presentation, as I said, there are a couple limitations with Azure DevOps and KEDA. The first is that you need to have at least one agent registered in your agent pool, otherwise the scaling and the queuing of pipelines won't work, and also the licensing of Azure DevOps will limit the amount of parallel jobs you can execute. And there are also some limitations when you use KEDA. For example, when you cancel a pipeline, the pods will continue running. They won't be cancelled and not removed. And also, KEDA does not remove completed pods, so they will just be around and do nothing. And the same in Azure DevOps. The offline agents will continue to stay in the agent pool. The solution is to have another pipeline or a cron job inside Kubernetes that runs, for example, once a day and just cleans up all these resources. And then my personal opinion about KEDA in production. Microsoft uses KEDA for its own services. So for example, the Azure Container Apps that were released I think a year ago is quite a popular service, is using KEDA, and also the Azure App Services in Azure Arc is using KEDA for the scaling. And I think if Microsoft is confident enough to run it in Azure, I can be confident to run it in my own projects. And KEDA has come a long way. The first version was released in November 2019, and currently we are at version 2.10, and there are over 6,000 stars on GitHub. And there's a great community, many new features, so I don't see any reason why not to use it. And with this, we are at the end of the presentation. I provided some resources so you can find the demo application on my GitHub, and if you scan this QR code, you will also find the presentation of today. If you have any questions or want to reach me, as I said, contact me on LinkedIn, Twitter, or via my blog. And with that, thanks for watching.